We're going to learn how to integrate using partial fractions. So for the first problem, let's just say you're trying to do the integral of 7 over x squared plus 3x minus 4. So first, you want to get rid or factor out the bottom. So
Clover Kramer to the office, please. Clover Kramer.
-1 x plus 4. And then as soon as you do that, you split them up now. So you have a over x minus 1 and b over x plus 4. Then you need to find the common denominator, so you have to multiply this one times x plus 4. So then that means you have to multiply this one times x minus 1. So whatever you do to the bottom, you have to do to the top. Multiply this one times x plus 4. And then when you try to find what a and b are, you just set a times x plus 1 equal to 7. And then, x. This will be, a times x plus 4. Okay, so then you make x equal 1. So then that will cancel the b out, and you don't have to worry about that anymore. So you just have a equals x plus 4. So x is actually 1 in this case. So then it'll just be 5a equals 7 divided by 5 divided by 5. A equals 7/5. And then to find b, you just do the same exact thing, except this time you're going to set it equal to -4. So x equals -4. And that'll cancel this a out, and then it'll make it 0. So then b, -4 minus 1, so b, -5b equals 7, because whatever, you want to set it equal to whatever the numerator is of the very first integration problem. So in this case it's 7, so you set -5b equal to 7, divided by -5, divided by -5, b equals -7. Yes. Okay, so then as soon as you do that, you reset up your equation. So then a is 7/5 in this case, so you do 7 over 5 and then you do the original one. You don't worry about the common denominator anymore since you already found a, so then it's just x minus 1. And then, so I guess you could rewrite it like this, so it would be easier. It would just be 7 over 5 times x minus 1. And you add whatever b is, which is -7 over 5 times x plus 4. And then you integrate both of these. Where's the x? Okay, so you integrate both of these and you'll get 7 natural log absolute value of x minus 1 over 5. And then plus -7 natural log absolute value x plus 4 over 5. Where's the extended page? Except I think I'm done. Scroll down. Right, this is... Okay, perfect. And then for the next example, we're going to do the integral of 8 over 3x cubed plus 7x squared plus 4x. Okay, so in this case, you still need to separate the bottom. So you'll have 8 over x, you can factor that out of each term, and then that will leave you with 3x squared plus 7x plus 4. And then from there, you factor this one out, and you'll get the integral of 8 over x times 3x plus 4 times x plus 1. Okay, so then once you have that part, since we have 3 different partial, these will be 3 different partial fractions, so we'll have a over x plus b over 3x plus 4 plus c over x plus 1. Okay, and then from there we do the same exact thing that we did last time. We have to find the common denominator. So in this case you have to multiply x times 3x plus 4 and x plus 1. So a will equal, so you have 8 equals, since you want to set all these equal to the numerator of the integral again, just like we did last time. So it'll be 8 equals a times 3x plus 4 times x plus 1. So you have to find the common denominator, so whatever you do to the bottom, you have to do to the top, and that's the two things you have to multiply to get the common denominator. It'll be plus b times x times x plus 1, and then it'll be plus c, and you'll get times x times 3x plus 4. Okay, so then you have to set a value to where you can get rid of two of the values. So in this case, to find a, you want to set x equal to negative 4/3. X is negative 4/3. And once you do that, when you plug it in, you'll get rid of all the ones that, actually this is to find b, so you'll get rid of a, and you'll get rid of c, because they're the ones that have 3x plus 4. So then you just do 8 equals b times negative 4 over 3 times negative 4 over 3 plus 1. So then, once you do this, negative 4 over 3 plus 1, it's just negative 1/3. Negative 1/3 times negative 4/3. Oh. Negative 1/3 times negative 4/3 would be 4/3. B equals 8. And then you want to multiply by the reciprocal, so, or divide by the same thing, so 4/3, which is like multiplying by 3/4, so then you multiply this one times 3 over 4, be 24 over 4, you get b equals 6. Okay, and then from there, so now we can try to find c if we set x equal to negative 1, because that'll get rid of the a again, and then it'll get rid of the b also, because they will equal 0, so it'll multiply all out to 0. So it'd be c -1 times -1 times -3 plus 4. So you'd get -1 times, or +1 times -1, so it'd be negative c equals 8, divided by -1, divided by -1, is c equals 8. Or negative 8, I guess, sorry. And then to find a, you set, you just set x equal to 0, because then that'll get rid of this one. It'll get rid of b and c, so x equals 0. So it'll be a times 4 times 1, it'll be 4a equals 8, divided by 4, divided by 4, a equals 2. Okay, so then after that, once you've done all that, then we do the same thing as we did last time, where we get the original. So we know the a value, and a was originally over the x, so we put 2 over x plus b, which was 6 over 3x plus 4, and plus c, which was -8 over x plus 1. Okay, so then once you do that, you integrate each one, integral, 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 you get 2 natural log absolute value of x plus then b, so it'd be 6 over, so it'd be 6 natural log absolute value 3x plus 4 over 3, because when you integrate this one, you have to do the chain rule. So when you integrate, or when you usually derive, you multiply by the derivative side, but in this case you have to divide, because we're doing the integral. So it'd be 6 natural log of absolute value 3x plus 4 over 3. It'd be plus -8 natural log absolute value of x plus 1 absolute value, and plus c. And you're done.